This is Mr. Beck Does Your Homework, AP Physics, Homework 5.2, questions 10, 11, and 12. Question number 10, a mass of 358 grams, so M equals 358 grams, is connected to a light spring of force constant, 24 newtons per meter, so my K equals 24 newtons per meter. It oscillates on a horizontal frictionless track. The amplitude of the motion is 3.3 centimeters. Remember, if you did the last question, you know that that is oscillating from all the way compressed this way to all the way out this way, where the spring will be very stretched. So over at either end, I know that my velocity is zero. My velocity is zero. So here, all the energy is stored as my potential energy in the spring. Here, all my energy is stored as potential energy in the spring. And then I've got this spot in the middle where the spring is relaxed, because here it's stretched, here it's compressed, here it is not stretched or compressed. So here in the middle, I'm going to have my maximum velocity, and it's all going to be KE. So the amplitude of the motion is 3.3 centimeters. That's telling you this distance is 3.3 centimeters, and you know that that is going to be the x. That's going to be how far the spring is compressed. So the amplitude is x, is going to be 3.3 centimeters, which is the same as 0.033 meters. Calculate the total energy of the system. Well, if I'm just looking at this spot here, that's pretty good because I can look at the energy in the spring, and that's all it's got, because it can't fall and it's not moving, but it's got a compressed spring. So I know that the potential energy of the spring is going to be the total energy of the system is 1/2 kx squared, is 1/2 of my k is 24, my x is 0.033, and don't forget to square that. So that'll give me my potential energy in the spring, which is the total energy in the system. Question 11 says, what is the maximum speed of the mass? Well, here in the middle, where the spring is neither compressed nor stretched, that's where I'll find the maximum speed. That's where that block is moving quickest before it's decelerated, because as soon as I pull the spring this way, it's got a force going back that way. As soon as I put the spring this way, it's got a force going back that way. So here is where the force is zero just for a minute, and it's got its maximum speed. Anywhere past there, it's going to be decelerating until it stops. Then it's going to accelerate this way until it passes through the center, and then anywhere past that, it's going to decelerate again, but to the right until it stops. So here is all my kinetic energy. That's where I'm going to have the maximum speed of the spring. So once I have this amount of energy, well, at the maximum speed, it's all kinetic energy. So I can take this number and say that equals to 1/2 mv squared and solve for v. Now it says, what is the magnitude of the velocity of the mass when the displacement is equal to 1.2 centimeters? 1.2 centimeters. Well, that's the displacement from rest is 1.2 centimeters. So now I want to find the velocity. Well, now I've got the same amount of energy, but now this same amount of energy is going to be some PE from the spring and some KE. So this total amount of energy is going to be 1/2 kx squared, where x here is going to be 1.2 centimeters. So x is going to be 0.012 for me, plus 1/2 mv squared, and you know the mass, and you know the k, and you know the x now, so you're solving for v. So now it's just a little bit of algebra to figure out that v is going to be some number. Don't forget to square root.